going to go over lesson 1.5. We're doing this after school because the lesson, when we did it in class, it didn't work. Just saved to my computer. So here we go. This topic is rationalizing denominators. It's one of the most important topics we do here, and it goes forward into your Math 30-1 as well as your Math 30-2. So it's a good topic for us to be going over. There are 3 requirements that must be met in order to simplify quotients of radicals. So this unit we've been talking a lot about simplifying radicals. Now we just need to remember there's a few things that you can't do. The first thing is you won't ever write your final answer where there's a fraction inside the radical symbol. So these 2 right here that I've circled, you would not be able to submit those as final answers because the fraction is underneath the root sign. Instead, we previously used to write these as square root 25 over square root 6. And we'd break it up into 2 radicals. But now, if we look at the second thing that we now must do, is we no longer let the denominator be a radical. This means this answer right here would no longer be acceptable because you have a root 2 on the bottom. This one, you have a root 5 on the bottom. That's no longer going to be acceptable throughout the rest of your time in math. So in Math 20-1, Math 30-1, Math 30-2, all of those classes are going to expect that you get rid of those radical signs that are on the bottom. And finally, you also can't have a negative value on the denominator. That's really easy to fix. We don't really talk too much about that because you can really just move your negatives to the top or to in front of the fraction. So those are pretty simple to deal with. But what we haven't ever dealt with before is this number 2. We've never dealt with what to do if there's a denominator on the bottom, and that's what we're going to do today. So the very first thing, they show you a little review of stuff we've already been doing. You take a fraction underneath the radical sign. You can break it up into 2 pieces. So now instead of having the square root of 36 over 4, you have the square root of 36 divided by the square root of 4. And that was useful for us before because the square root of 4 is just 2. The square root of 36 is just 6. And you have a basic fraction. You can simplify that to be 3. Again, that should just be a review of a previous topic we did, where you're just taking this rule right here and applying it. And that's saying that a radical with a fraction underneath can be broken up into 2 radicals that are still in fraction form. The first step to ever simplifying these things is to always try to do that, what we had just done. Break it up into 2 and then divide, because it's so much easier to do that first than to try to simplify later on. And maybe it can cut down your work really, really fast. So if we look at A, we have the root of 30 divided by the root of 6. Root 30 and root 6 don't come out to be anything nice. Root 6 would be a weird decimal. Root 30 would be a weird decimal. But you can also work our rule in reverse. And you could do the square root of 30 over 6. And that seems kind of counterintuitive. We're going backwards now, and that's kind of weird, because usually we say we don't want a fraction under a radical sign. But the reason we do that is just to show how easy it is to simplify. 30 divided by 6 is just 5, which means this thing we have here is just really root 5. And the reason we combined it into 1, in this step right here, is just to do a nice little demonstration to show you that the 30 and the 6 can actually be simplified together. We don't need to do that step, we just do it to show that it's a nice, easy way of dividing 30 and 6 to get 5. Okay, B. We're going to do the same thing. The very first step is always to simplify. When you're simplifying, remember, coefficients divide with coefficients, and radicals will divide with radicals. So, the very first one, 21 divided by negative 7. That gives you 3. So we know our final answer is going to have 3. And we have 50 divided by 2 as our radicals, and that's 25. Sorry, that's a negative 3. 50 divided by 2 is 25, so we have root 25. So this simplifies down to be negative 3 times root 25. Root 25 is just 5, so it's equal to negative 3 times 5, equal to negative 15. And you see how easy this can be if we just simplify. We simplify our coefficients with our coefficients. We simplify our radicals with our radicals. And life is pretty easy in these questions. You will get questions like this where you can just do these simple steps and get it all right. So let's look at C. We have 6 times the root of 24 and divided by 18 root 3. Remember, coefficients go with coefficients. And radicals divided with radicals. So, the first part, 6 divided by 18. That is equal to 1 over 3. Perfect. So we know our answer is going to have a 1 over 3 in it. And now we have 24 divided by 3. And that gives us 8. So we know we're going to have a root 8 over here. Now, that root 8 is in the numerator, the 3 is in the denominator, but as we remember in our previous topics, root 8 can actually be simplified. So we're going to change this to become root 4 times root 2 divided by 3. The reason we broke that up is because root 4 is just 2. So now it's 2 times root 2 divided by 3, that's your final answer. Awesome. This continues on for D, E, and F. Let's do D together. Remember, our first step is to simplify. So if we look at 27 and 16 over here, they're in red, like the way that pops up on the board. Over here. 27 does not divide nicely when you have 16 going into it. But if you look at this question right off the bat, you should notice that the square root of 16 is just 4. And on the top, we still have root 27. So root 27 divided by 4. Pretty easy. On the top, root 27 can be broken up. Root 27 can change into root 9 times root 3. And it's also divisible by 4. Root 9 is just 3 though, so we have 3 root 3 over 4. Boom, final answer. These are getting pretty easy, I hope. Probably making lots of sense. Okay, look at E. Remember, simplify your coefficients with your coefficients, 6 by the 12, and simplify your radicals with your radicals, the 30 and the 8. The 6 and the 12, right off the bat, I'm going to give you 1/2. And the root 30 divided by the root 8, is that going to simplify nicely? Well, 8 does not go into 30, so that doesn't help us. But what we could do is we could break up the root 8 to be root 4 times root 2. So let's see that and see where it gets us. Root 4, root 2. And on the top we still have root 30. Okay, that simplifies to be root 30 divided by, remember the root 4 is just like timesing by 2. So we have 2 times 2 is 4, and root 2. Now we can simplify again. The 30 and the 2 still go together. 30 is divisible by 2, real nice. And now we have root 15 over 4. The root 15 came from 30 divided by 2. Alright, the last one. And this was the hardest one on this page. This was the one we had the most difficult with in class. So we're going to go over it nice and slow. Make sure we get all the steps. First thing you want to do, you want to simplify. Remember, coefficients go with coefficients. That 2 in the denominator. The only way you can divide it is if it divides into all 3 coefficients. In this case, it does. That 2 divides into 6, 10, and 8. On the first one, we're going to get 3. The 10 will turn into a 5. And the 8 will turn into a 4. Fantastic. The next part. Radicals have to go with radicals. So that 3, can it divide into 18? Yes, it can. It gives you 6. So the first one is now 3 times root 6 plus 5. And can the 3 go into the 24? It can. It's 8. So now you have plus 5 root 8. And the last one, 6 there, root 8. And the last one, we have 12 and divided by 3. It does. It's root 4. Perfect. And you look at that, you see we divided that out pretty nicely. But we're not done yet because we can still simplify a little bit further. Can we simplify the root 6? No, we cannot. There is no perfect square that goes into 6. Can we simplify the root 8? Yes, we can. Remember, we could just change it to be root 4 times root 2. Root 4 is just 2. 2 times 5 is 10. So we have a plus 10 root 2 on this one. And the other one is root 4 is just like timesing by 2. So now we have plus 8. And that would be your final answer. Fantastic. That's the best case scenario when we're doing these questions. Best case scenario, things simplify nicely. You know, in the real world, things don't simplify nicely. In fact, it very rarely simplifies that nicely. We're used to seeing a lot more difficult ones to simplify, like this example right here. 1 divided by root 2. That root 2, it can't divide by anything. Right? There's nowhere to simplify here. Can root 2 divide into 1? No, it cannot. No. It can't simplify. So we have to come up with a new method of getting rid of radicals on the bottom. Because remember, right at the beginning we said it's not okay to have an answer like that. You're not allowed to have a radical on the bottom. So what we do is we do something called rationalizing the denominator. Rationalizing the denominator. That's the title of this slide. Pretty suiting. So what you need to do is you need to take whatever the radical is on the bottom. And in our case, it's root 2. And you use that radical to rationalize the denominator. Which means you multiply your entire fraction by whatever you saw on the bottom. And the reason they do that is because now in your denominator you have root 2 times root 2, which is just 2. Boom. Perfect. Radical's gone. So that's what we were trying to do. On the top we have 1 times root 2, which is root 2. So your final answer would be root 2 over 2. Which, is that an acceptable answer? Yes, it is. Does it have a fraction under a radical sign? No. Does it have a negative on the bottom, on the denominator? No. Does it have a radical on the bottom? No. Then we're good. We've done the 3 things we're allowed. We don't have the 3 things that we're not allowed to do, so we're good to go. Now the question some people had in class was, why are you allowed to multiply by root 2 on the top and the bottom? That seems kind of weird. And the reason we're allowed to do this, the reason we're allowed to mathematically multiply by root 2 divided by root 2, is because root 2 divided by root 2 is just 1. We haven't done anything to our original question. We multiplied it by 1. You can multiply anything by 1 and it's still the same thing. We didn't change it at all, we just changed the way it looks. We just changed the way it's represented. And we did that by multiplying it by whatever the radical was on the denominator. Now, like all math, it's a lot easier to see how these are done when you actually practice them. So let's look at rationalizing a monomial denominator. Monomial. 1 term. So we only have 1 term on the bottom, and that's key. If we look at this question, first step is still always simplify. So can we simplify a? Can we divide root 5 into root 5 over here? Yes, we could, but there's no root 5 here to also divide into. And you have to be able to divide into every term in the numerator for it to actually work. So we can't simplify this the way we used to. So we have to do something new to get this off the bottom. And what we do is we rationalize the denominator, which means we multiply by the square root of 5 on the top and the bottom. And we chose square root of 5 because that's the radical that we saw on the bottom, on the denominator. And by doing this, we will see that the root 5 times the root 5, it gets rid of the root sign. Remember, root 5 times root 5 is just root 25. And root 25 is 5. So that's why it cancels itself out nicely on the bottom. On the bottom, we're just going to have 5. Now on the top, we have a little bit more of a pickle. This root 5 needs to distribute into both things, both terms on the top. So the first one will be 4 times root 5 times root 5, which becomes 4 times root 25. Remember, if you're multiplying radicals, radicals multiplied by radicals, coefficients multiplied by coefficients. So for the second term, we have negative 2 times root 5. There's no other coefficient to multiply with the 2, and there's no other coefficient to multiply with the root 5. So that's what you have on the top, just 2 root 5. Now we can simplify this a little bit. Root 25 is 5, so our answer is actually 20 minus 2 root 5 over 5. The reason we did that is because there's a radical in the denominator. Mathematically, we do not represent things with radicals in the denominator, and it will no longer be acceptable in any of your math practices to have a radical in the bottom. In this class, we only ever deal with square roots in the bottom, so you'll never see anything else. You'll never see a cube root, you'll never see a fourth root. If you do see a cube root or a fourth root on the bottom, it means you can simplify somewhere. You won't ever have to rationalize a cube root on the bottom. Won't happen. Okay, let's try B. The first thing you always want to do is try to simplify. We do a quick check. 12 and 2 do divide evenly, but 12 and 5 don't, so we can't simplify this at all. Let's rationalize the denominator. So we multiply by 12 on the top and the bottom. Sorry, multiply by root 12. The reason we do that is because on the bottom, root 12 times root 12 is just 12. On the top, that root 12 distributes in 9 root 2 times root 12. Remember, coefficients multiply with coefficients, radicals multiply with radicals. The 9 has nothing to multiply in this case, but the root 2 and the root 12 do multiply to be root 24. Now the second term, the same thing, the 3 has nothing to multiply with, but the 5 and the 12, they do multiply. So now we have root 60. We're not done yet because you always finish off with simplification. So the first thing we want to look at is the 24 and the 60. Can I take any perfect squares out of those numbers? Well, the 24 I for sure can, because 4 goes into it. 4 goes into it 6 times. So I could rewrite the root 24 as root 4 times root 6. And the 60, am I able to do anything with that? Remember, I said in previous lessons, you want to find the largest perfect square that divides into 60. So let's check through. Does 36 divide into 60? No. Does 25 divide into 60? No. Does 16 divide into 60? No. Does 9 divide into 60? No. Does 4 divide into 60? And it does. So if you punch that in your calculator, you should find that it goes in, I believe, 15 times. So we could rewrite this as root 4 times root 15. Perfect. Root 4 is the same thing as just a 2. So it's like timesing by 2. That's going to change our answer now to be 18 root 6 minus 6 root 15. And it's all divided by 12 still. Now you're thinking we're done because we've simplified our radicals, but we're actually not done because we can simplify our coefficients in this question still. There's a common multiple of 18, 6, and 12. And that common multiple happens to be 6. So we can divide each one of those coefficients by 6. And that will give us our final answer. So our final answer would be 18 divided by 6 is 3 root 6 now. 6 divided by 6 is just going to be 1, so we are left with just root 15. And on the bottom, 12 breaks down nicely to just be 2 when we divide out a 6. Fantastic. These questions, you can see they can be long. There's so many simplifying steps. And there's lots of different paths that you could have taken to get to this final answer. You could have simplified the question right off the bat when you notice on the bottom that the root 12 actually is root 4 times root 3. And you could have simplified that right off the bat too. So there's many ways to do these questions. So if you took a different route but got the same answer, that's okay. Alright. C, you can try on your own at home. If you try it at home, your answer, I believe, should be 5 on the bottom, and then 10 plus 4, and that'll be 14, sorry, that's not the answer, it's plus 4 root 5. That should be your answer. Try that one on your own, see if you actually get it. If not, rewind a little bit, check what we did on A and B, and see if it didn't, why it didn't work out for you. Okay. Here's a few more questions for you. They're all the same except for F. So I'm not going to do D and E because nothing has really changed for us, but we would have done them in class, you would have done them on your own, and then we would have gone over them. But F, we would have done together because there's something different about F. What's different about F? Well, if you look at the denominator, you see that there's a coefficient. There's a 2 there. We've never dealt with anything where there's a coefficient. So the question here becomes, what do we rationalize with? Do we rationalize with just root 3 over 3? Or do we rationalize with 2 root 3? Oh, can't draw over there. It's off the board. Or do we rationalize with 2 root 3? I mean, I've been saying you use whatever's on the bottom, but we've never had a situation with a coefficient. You're still multiplying by 1 in either case, and I'm going to tell you right now that neither one is wrong. If you were to multiply by 2 root 3 root 3, the blue, that's correct. That's fine. You're only multiplying by 1, right? Nothing's going to bad happen. But by doing the blue version, that's longer. By doing the red version, you're still going to get rid of your root 3s, and that's our goal. The red version is the short version. That's quicker. So what we want to use is always the quicker question. So we're going to use the red question. We're going to multiply only by root 3s. We don't worry about the coefficient, the 2. And the reason we don't worry about it is because you're allowed to have a 2 on the bottom. You're not allowed to have a radical on the bottom, so that's what we need to get rid of is the radical on the bottom. So that's all that should have our attention right now. We're going to multiply this by root 3 divided by root 3. And on the bottom, you will now have 2 times 3, which is 6. And on the top, you're going to distribute that root 3 in to both things. Remember, radicals multiply with radicals, coefficients with coefficients. So the first one would be 4 root 6. And the second one would be 6 root 15. If you're not quite done, you always want to simplify. So can you simplify your radicals? Well, 6 doesn't break down into anything nice, and 15 doesn't break down into anything nice, so my radicals are okay. Now, are my coefficients okay? 4, 6, and 6. Is there a common multiple of all 3 of those? The answer is yes. 2. 2 is the greatest common factor of those 3 things. It's the greatest common factor of all 3 of them. I've been saying multiple, which isn't really the proper terminology. What I was looking for was the greatest common factor, not the lowest common multiple. But is there a number that divides into all 3 of those things? And the answer is yes, 2. 2 divides into all those things. So we're going to divide a 2 out of all those things. So it becomes 2 root 6 minus 3 root 15. And it's all divided by now 3. And that's your final answer. Had you done the blue version, where we multiplied by 2 root 3, we would have had to factor out a bigger number at the end. That's the only thing that would have changed. Your final answer would have still been the same. Okay. So far, remember we said it was only monomial denominators. Now we're going to have to deal with binomial denominators. So that's where you see a radical plus something or a radical minus something, like this. And to be able to get the radical off of the denominator of a question, when you have a binomial, you can't just multiply by the root 3. That wouldn't work. So if we tried our regular approach of multiply by root 3, the first one would cancel, but then you would have 5 root 3. So it wouldn't help us, because now we've just created a radical somewhere else. So they came up with a new problem, or problem-solving method, using something called conjugates. And a conjugate is the exact same binomial, but with a different symbol. So see that the root 3 plus 5, that plus is different from the root 3 minus 5. And the reason we do that is it'll cancel out our 2 middle terms when we FOIL. Remember, binomial times a binomial, you have to FOIL. And your outside and your inside terms, when you do this cool thing using conjugates, your outside and your inside terms actually cancel. So right below, they've done a nice little example for you and drawn it out. We have the expression, and we have the conjugate. Remember, the way you can tell it's an expression or conjugate is the symbol is different. The next step, they have FOILed them out for you. So they've multiplied and distributed it properly. And you get root 9, and then you get 5 root 3 and 5 root 3. But because the symbols were different between the expression and the conjugate, you'll notice that these symbols are also different, meaning that they cancel each other out. If you have 5 root 3 and then you minus 5 root 3, you have nothing left. So your final answer becomes root 9, which is just 3, minus 25. So your answer is negative 22. And we're going to see how effective that can be for us. So, a nice little example here, just practicing FOIL. I'll go through it. Remember, FOIL is first outside, inside, last. So your first terms. Root 3 times root 6 times root 3 times root 6 will give me 9 and then root 36, which is really just 9 times 6, which is really just 54. Perfect. The next thing we want to do, outside terms. So this is an outside term, this is an outside term. 3 times negative 2 will give me negative 6, and the 6 times 3 will give me root 18. Inside terms. The inside terms are the 2 that are on the inside. 2 root 3 times 3 root 6. You'll notice that you get 6 root 18. Alright, it's a little messy. It's getting a little squished up here. And finally, your last terms. So you have 2 root 3 times negative 2 root 3. You'll get negative 4 root 9, which is really just negative 4 times 3, which is really just negative 12. There, we foiled. And you'll see that the outside and the inside terms right here, the blue and the green, they cancel each other out. I have a positive 6 root 18 minus root 618. They cancel each other out, which is perfect, because now you're just left with 54 minus 12. And your answer there is just 42. The answer to everything. Perfect. So we use these conjugates to solve issues like we see down here in example 2. What we see is we have a radical on the bottom. And a radical on the bottom is no good to us. But we also have 2 terms on the bottom, which tells us we can't rationalize. Anytime you see 2 terms on the bottom, that's telling you right off the bat that you have to use a conjugate. You have to. Okay, let's do this question. First step, always to simplify. It'll always be to simplify. So let's simplify this question. Before we even get into the messiness of conjugates, we're going to simplify this question. Root 8 changes into root 4 times root 2. So root 8 would be now just 2 times root 2. So we have 10 root 2. Second term, we can't do anything with that. Root 2 does not simplify here, so we're good. So minus 3 root 2 still. Now on the bottom, root 32. Root 32 divides nicely by 16, which is a nice big perfect square. So we're going to change that into root 16 times root 2, and root 16 is just 4. So now we have 4 root 2, and we have plus 3 root 2. And you're going to see something. We could have done all that hard work and done conjugates, but because we simplified, look how easy this comes. On the top, 10 root 2 minus 3 root 2 is just 7 root 2. On the bottom, 4 root 2 plus 3 root 2 is just 7 root 2. 7 divided by 7 is 1. Root 2 divided by root 2 is 1. 1 is your answer. Boom. Didn't have to use conjugates. Didn't have to simplify later on. It was actually a quick, easy question because we simplified first. Now, some questions that don't simplify. Then we're going to have to do something a little bit different. So, question B, simplify first. We can't. There's nothing that goes into 5, 7, and 3. Nothing can work here. So we have to somehow get that radical off the bottom. But we can't rationalize the denominator because we have 2 terms. So we have to use the conjugate. Remember, the conjugate is the same thing you have on the bottom, but with a different sign. So that sign right there has to be different than that sign. That's key. If you don't do that, it won't work. And then you multiply by the same thing on the top. On the top, you will get negative root 35 minus 3 root 5 on the bottom. I know that my first and last terms will be the only things remaining. My outside and my inside terms will cancel out. So I'm only going to do my first and my last. My first term, Root 7 times root 7 will just give you 7. Now my last term, negative 3 times 3 will give me minus 9. So now we have negative root 35 minus 3 root 5 divided by negative 2. We're not done. We have to simplify. Does anything divide into 35? 16 does not. 9 does not. 4 does not. Root 35 is as simple as it goes. Root 5 also as simple as it goes. But we're still not done. Check the coefficients. Does anything divide into the 1, which is here? There's an invisible 1. 3 and 2. No, nothing divides into it. But we're still not done. We're still not done because there's a negative on the bottom. Which, if you remember correctly, you're not allowed to have a negative on the bottom. So what you want to check first is, can you cancel that negative out of the bottom and the top? Meaning, can you divide a negative 1 out of every single term? And the answer is yes. So you can change all of your signs, and now you have root 35 plus 3 root 5 divided by 2. That's your final answer. Remember, we don't leave our final answer with negatives on the bottom. Okay, I'll do one more, and then leave the last one for you to try and see if you can figure it out on there. So, we look at this question, we're going to look at C, and we know the first thing is to simplify. We can't simplify, so we have to rationalize the denominator, but we can't because there's 2 terms. So now we go on to our next checklist, and our next checklist is to use the conjugate. So I'm going to multiply by root 3 plus root 2. Remember, it's whatever's on the bottom, but with a different sign. On the top, if we FOIL, our first term will give us 5 times root 9, which is really just 5 times 3, which is 15. Our outside terms will give us plus 5 root 6. Our inside terms will give us plus root 6. And our last terms will give us plus 2. Divided by, it's a conjugate. We have an expression times a conjugate, so I know that outside and the inside terms will cancel. The first term will just be 3, and the last term will just be minus 2. The 3 came from root 3 times root 3, and the minus 2 came from negative root 2 times root 2. We can simplify this a little further. So on the top, we have 17. Might as well combine those big terms. So these two connect. 15 plus 2 is 17. And if you have these, they're like terms too because they're the same radical. They're both root 6. So we have 5 root 6s plus 1 more root 6. That means we have plus 6 root 6. On the bottom, 3 minus 2 is 1. But you don't really write that as the final step. Because you can divide anything by 1. We just leave that as our final answer. You don't need to write the divide by 1. You always check to see if you can simplify. I already did that. You can't simplify. The root 6 doesn't simplify. And the 17 and the 6 are fine on their own. Okay, I want you to try D on your own. It's the last question of this long lesson. So if you've made it this far, congratulations. If you're not completely confused, you said it. If you are confused, you can always ask questions, come to school, you can email me, or you can rewind and check the lesson a little bit more, see if you can't figure out the problem on your own. D. If you take a look at it, try it on your own, and you should be able to see. Actually, what I want you to do is I'm just going to pause the video, then try it on your own. I'll still do a detailed solution. I'm going to go pretty quick through it. Okay, so hopefully you've tried the question, you've hit play back on the video, and now you want to see if you got the right answer. So, first thing you want to do is try to simplify. You can't simplify this, so you need to go right into using your conjugate, which is 5 board just stopped working. 5 minus 4 root 2 divided by 5 minus 4 root 2. On the top, what you're going to get is you're going to get 30 root 3 as your first term. Your outside terms is going to be negative 24 root 6. Your inside term is going to give you minus 10. And your last term is going to give you plus 8 root 2. On the bottom, that just looks so nice. Yeah, that's a lot of crappy terms on the top. On the bottom, I know my first and my last terms are going to be the only thing left because we used a conjugate. So the first terms would give me 25. The last terms would give me negative 16 times 2. So I'm going to do that up at the very top of the board. Just in case you aren't remembering how to do multiplication of radicals, we have 4 root 2 times negative 4 root 2. Remember, coefficients go with coefficients. So negative 4 times 4 is going to give me negative 16. And the radicals go with the radicals. Root 2 times root 2 gives me root 4, which is the same thing as just 2. So on the bottom you have a minus 32. Perfect. At this point we have done the hardest part of this question, which was using a conjugate. Now we just need to simplify. So on the top, can anything simplify? Root 3, no. Root 6, no. Root 2, no. Do we have any like terms? No. So on the top, you're actually good. Nothing needs to change. On the bottom, however, we have 25 minus 32, which is the same thing as just saying minus 7. But we're not done, because on the bottom, you have a negative, and you're not allowed a negative on the bottom. So how can you get rid of a negative on the bottom? And the answer is simple. See if you can divide a negative out of every coefficient. You can't. So you notice that there's no negative in front of the 30, no negative in front of the 8. But what you can do is multiply the top and the bottom by negative 1. So if we multiply the top and the bottom by negative 1, all it does is it changes all the symbols you've seen. So now your final answer is going to be negative 30 root 3 plus 24 root 6 plus 10 minus 8 root 2, all divided by 7. Now, we're complete. We're done. It's the final answer. You can't simplify that any further. That is the final answer that you are looking for. So remember, if you have any questions, you can always ask me at school or email me. My email address is mkennedy@cesd73.ca. Remember, the CESD stands for Chinook's Edge School Division. 73 because it's the 73rd division. I hope that you learned lots. See you tomorrow at school.